Hi, so my name is Steve Bradshaw and I am joined by Matthew Perch. I am an IBM champion and Matthew is new to the platform, and we thought rather than just teach him within the Rogan organization, we'd share some of the courses and hopefully they'll be of some use to you. If you do find them useful, please put the comments in there, but without further ado, Matthew, say hello.
Hello.
There we go. There's Matthew. He's new and he's learning. Hopefully you're going to be learning too. So this session is all about an introduction to IBM in specifically and power systems in general. You need to know a little bit about the hardware that runs on in order to really appreciate the value of the platform itself. So let's crack on. Let's start with a quick history lesson. A lot of people still call this platform an AS400, okay? And some people call it an I-series. That's fine. If you're as old as me, you can remember all these things. So that's a quick history lesson. The box in the top left-hand corner that you see up there, that, ladies and gentlemen, is an AS400. That's what they look like when I started my career, had hair, spots, and was even younger than Matt. So that's 1988 when that was launched. There were beige boxes, and just to put that in context, each one of those weighed about a quarter of a ton and was probably about 6 foot tall. So it's not quite a telephone box, but you could stand inside it. Right? And that is fantastic. They were an incredible box. I'm not going to go back beyond that, but they were wonderful of their time. Brilliant. But time has moved on and it's not the same platform. So as we move through the eras, into 1995, we moved from a 48-bit to a 64-bit processor. Great, fantastic. We were the first platform in the world to do that. And they do dynamic transformation of bits. There's no recompilations, no problems with boundaries on our machines. We just moved the software across and it did a conversion. In 1999, we started doing LPARs. LPARs, ladies and gentlemen, logical partitions. That's what we call VMs on IBM systems, virtual machines. So if you're a sort of a Linuxy person, Wintel person, and you like to talk about VMs on VMware or KVM, whatever, we use PowerHA with LPARs, logical partitions. And we started doing that some 23 years ago on IBM. So we have logical containers. What is a VM, just in case you're not sure? What is an LPAR? It's when you have more numbers of physical discrete systems on one piece of hardware. So you might have one physical server with 10 LPARs on it. So there's 10 virtual servers and they're all autonomous from one another. Okay. Then in around 2000, the name was changed from AS400 to I-series, still a very popular name with people who joined after the millennium. And it was a definitely good brand name. And I-series was both the hardware and people use it to describe the platform as well, which was really i5OS back then. It was called OS400, but it was the AS400. Okay. We started running Linux on IBM I platforms in 2001. So it's more than 20 years we've been able to run Linux on IBM I. Linux is a new phenomenon to many people, but not us. Ironically, we got Linux before PACE, the Portable Application Server Environment, i.e. the ability to run AIX Unix binaries on IBM I. So that's another thing we can run on IBM I, not just OS400, i5OS, or now IBM I things. Those are the new names for the same thing as we move forward. But also in PACE, we can run some of these AIX Linux type binaries, Unix type binaries. 2007, we started to see two different sides merged together. This was what used to be called the P series and I series, the RS6000, AS400 in the old days, i.e. the Unix servers and the IBM I servers came together and we had power systems formed. And in 2008, we changed the name to IBM I. So for those of you paying attention, it's been called IBM I now longer than any of the other names, despite the fact that everyone still calls it I series or AS400. If you want to call it that, you're absolutely fine. Please don't treat it like that. Okay, AS400 is an old type of server, and IBM I can run these old workloads. They're fantastic, but also some modern ones too. All right, so moving forward, we started to see this generation of Power 6, Power 7, Power 8, Power 9. So 2008 saw that, as well as IBM I Power 6 servers. This is the processors that these IBM I AIX and Linux servers run on. And then about every 3 years, you get a new generation. So we have Power 8, Power 9, and guess what? There's Power 10s there now. So, there are some inherent benefits of an IBM I and Power server system. These are the reasons why they're popular. Those include the fact that, yes, you can see it's mature and secure, fine. So it's been around for a long time. So all of the hacking and the hardening has had plenty of time to get that done. And in that 30-year plus life of the product, right, yeah, it is still seen as one of the most securable platforms in the world. There's never been a native IBM virus that's ever been written or deployed. And we'll talk about why that might or might not be later, and how we can still be seen as vulnerable, even though that statement I just made about viruses is true. Right? It's continued growth and development. So a lot of people who call it an AS400 and use an older green on black application and don't do anything else at all would be forgiven, or could be forgiven, for thinking, well, you know, IBM's not doing anything to make this a better and more modern server. But there is continued growth, continued features that are being added all the time. And just to call a few of these things out, the ability to run open source applications on there now. So what are perceived as more modern and contemporary applications written in Python, R, Node.js, all of these things are available running alongside more traditional languages like COBOL, RPG, and C. So yes, that's just one thing. The fact that you've got active DB2 stuff, logical abilities to replicate, as well as physical abilities to replicate your data. There is continued development of this system, and we get patches every 6 months for major releases, every month for security releases, and the new operating system every 3 years. I'm going at a fair lick. If you've got questions, then feel free to cut in at any time. I realize that sometimes I'm hard to interrupt. The other thing that this platform gives you is this protected investment. If you wrote code back in the 80s, then it still runs without any recompilation, re-optimization, without any caveats at all. You could just load it and run it. And so there are plenty of people who say the best thing about an IBM server is that it's just so secure and so backwardly compatible. And there are other people who say the worst thing about an IBM server is that they are so securable and so backwardly compatible. I mean, if you can run code that was written in the 80s on a machine today and it's still fully securable, and some people go, well, it isn't broken, I'm not going to fix it, I'm not going to make it better. And that's a different story for a different day, but innovation and modernization is a continuing step-by-step process. So, but anything you write now will work in the future. Anything you wrote in the past will still work. IBM is amazing at that backward compatibility. And this whole idea of low cost of ownership or total cost of ownership comes through this self-management. So within the IBM operating system, you're gifted a security schema and the database. You can't have, they're literally all integrated. The I in IBM stands for integrated. That's what it is. The whole thing comes together, and they're not just bolted on top of one another. They're literally built together. That's why you can't separate them. So the idea of having some sort of database manager that sits there and has to look at the schemas and operate as you might with other large databases, it's just nonsensical. This is self-optimizing, self-tuning, self-healing system. So many IBM shops out there actually don't have an IT department. They have a box in the corner and they just crack on with it. And if they do have an IT department, quite often they've got no clue as to what IBM does at all, and they're still busy doing the Windows networking and firewall security. So these things do have a good running cost. Once you've got them, invest them, they tend to be very stable. I know many people who only restart their servers once every 6 months, and that's to install patches. Worse of all, I know people who only restart their server once every 6 years, i.e. they put it in, they use it for 6 years, and then they take it out 6 years later and put another one in. Yes, you really can do that, but please don't. Please put patches on there. It's good for the machine. So it's quite possibly the most open system on the planet. These protocols I was talking about, whether it's web services or SSH, whether it's traditional languages like RPG or more modern ones like R or Ruby, those are all there. And the connection services that you might expect, or all of the standard ones like the telnets, the SFTPs, the SNMPs, the SFTPs, the NTPs, all those protocols are there and are built into the platform, no extra cost. But whether it is the most open planet on the platform, that's up for debate. But one of the things that's definitely true is it's one of the most securable systems in the world today. Now, I'm not going to say it's secure as in by default, this is the hardest one to hack. When I mentioned about the viruses, that's still true. We'll put some caveats on that later as to how that's there's still risks that one has to be aware of. But all of the systems that you need for intrusion detection, application data support, auditing, they're all built in to the system. Now, the defaults aren't necessarily the best to make it the most secure. You can still do some tuning, but they're there. You're not going to get charged extra to put a firewall on the top, or to have the auditing, or to have a database schema that scales. You know, all of these things are in there, but a little bit of time has to be invested. And this is why we say securable rather than secure. If you look at some of the largest companies in the world, you know, particularly the largest banks and the largest insurance companies and the largest shipping companies, anyone who needs a database that has to do things in the right order, you'll find a very high percentage of them use IBM somewhere in their estate. So in the US, I think that's S&P 500, I think it is called. I think that sort of 85 to 90% of the people, the companies in there have an IBM in their estate. And we find the same with the FTSE 100. So all the big companies, you tend to find them in there. And we'll touch about that a bit more later. So a quick look at what these systems are from a hardware point of view. Those people like hardware, okay. The most popular systems that you see out there are these scale-out boxes. So they tend to be either 2U or 4U in their form factor, and they tend to have either one socket or two sockets with lots of cores in them. And so, you know, that'll run a typical enterprise. But we have some bigger machines in the E950s. You can basically start to stack these and get them to actually work together. In the E980s, even more so. And then some specific Linux and AI workloads. And of course, very more recently, we've had the Power 10 boxes come along. And so at the moment, we only have the enterprise ones as I record this. I'm sure very soon there'll be scale-out versions of the Power 10s. And these are also the big monsters. So absolutely superb. If you've got an airline to run, you know, these things will be up 24/7 and dealing with your millions of transactions per hour. Okay, so what is different about an IBM server? What makes it not an Intel server or not a Linux server? Well, I think that we can start to look at what it's good at is database. I think I was touching on earlier, is that if you need things to be done in a specific order, and you need to know that the transactions were actually committed or rolled back, the database elements of this is at the heart of what makes this system special. The operating system uses the database. The security uses the database. Everything is integrated together. So you can't bypass the database and you can't bypass security. They literally go hand in hand. Even the operating system is accountable to itself through security and database use. So your data is good, right? I think we've made that point. It's a good application server. So if you've got data, you normally want to do something with it. You don't have an application to do it. It's an application server. So maybe you've got an ERP system that might do stock control, sales, personnel management. Really good at that sort of stuff. You might need some traditional file serving so that you've got file exchange between multiple workstations, multiple servers. So I'm talking about sort of a map network drive or an NFS drive. So that's the SMB, CIFS, or NFS type protocols. So that it'll do that, and that's all built in. That's one of those areas where I say, although the IBM operating system itself inside IBM can't get a virus, if you are mapping a network server, so you've got a file directory, so it's now the G drive, or maybe the I drive, we should call it, on your PC, and you put a Word document which has a virus on it, it will sit on there and it just won't infect the IBM server. But in a way, it's the perfect host, that carries this virus. And so if someone else connects it with another Windows server, you could potentially pass the virus that way. So just the difference between IBM not being able to be subject to a virus, but the things that connect to it could. So you need to be careful about what you do and how you use the server. Just having this isn't a vaccine against all hack attacks. It's a file server. It's also a good web server. So by default, we've shipped an Apache web server in there for years, but you can also run Tomcat on there, Nginx, and a number of others now in the open source module. So there's an open source web server you like, chances are it'll run on here. It's got full print serving stuff on there, and of course that tends to be part of an application server. Maybe less so these days. when I first started, everything was printed out, looked at, underlined, ticked, and then typed back in again. Glad to say, for the sake of the planet, we're not printing quite so much. But even print services now might be printing to PDF and then archiving them. There might be digital prints, but there's still a surprising amount of paper out there. And of course, all of those services are built into it. If you want it to be an authentication server, like the equivalent of Active Directory, try not to use too many Microsoft terms, but those people who know what Active Directory does, it has its own methodology for that, and it uses the LDAP protocol, the Light Directory Application Protocol, if I remember correctly, to actually implement that and integrate with things like AD if you want single sign-on. And lastly, it's a collaboration server. So, if you wanted to have a mail calendar to do this server, you could. In this case, you can either roll your own, there's some basic mail services in there, or you can use Domino. So that's still there as an option, probably not so popular these days, as less and less people use on-prem mail servers, and we see more of that move to the cloud. And at the bottom there, I've just included a link to some of the IBM success stories, and it's just case study after case study of people who use I and why they do it. So there's probably 100 or more people who've actively gone out and said, no, not only do I use it, I want to shout about the fact I use it. This is why that's a good idea to use it. So that link's at the bottom if you want to click that and take a look for those people. All right, so what's the architecture of an IBM I server? What does it actually look like? How is it structured, and how is that different from a traditional server? Well, bear in mind, this has been the structure since 1988. What I'm about to describe to you will be more familiar these days for those people who use VMware, Hyper-V, or KVM. In this whole idea of an abstraction layer. So let's start at the bottom. There's hardware. I think we're all sort of used to that, fine. But our first level of abstraction we call the SLIC, the System License Internal Code. And the purpose of the SLIC was just to say, as you move between a Power 8 and a Power 9, where the hardware architectures could be radically different numbers of cores, different architectures of bus, the SLIC just abstracts it and says, okay, well, I'll do the translation for you in a way that we might say that VMware or Hyper-V would do from that Intel hardware underneath them. And so this is something, because we've done it for so long, it's made it so easy, and it's the reason why we're so backwardly compatible. And that sits below the IBM I operating system. So we've got the hardware, then we've got this abstraction layer called the SLIC, then we've got the operating system with its hook stands there, and then we start to do the application of data. So our application serving in our database serving. And integrated with that, of course, is all the security services that goes. So this model is starting to be emulated now by other platforms, and for good reason, because it's bloody brilliant. It absolutely is fantastic. You can move any workload between different types of hardware and not have to worry about driver compatibility or hardware compatibility. Just be known that if you're dealing with IBM I, you will be able to do it. You'll be able to do it in the future, and you'll be able to do it with any version of IBM I you had in the past. Okay, so what else can you do with this power server? Well, I've talked about the IBM I part of it. I should just call out that with a single server you see down there, so this is where the hardware comes in there, and this is basically what we're talking about with the whole SLIC elements, the hypervisor into the SLIC. Sort of crosses across this element. It's got a hypervisor where you'd share processes, you can share fractions of processes, where you'd want to share memory, where you might want to move adapter cards backwards and forwards. So that's all happening down here. But it's not just an IBM I operating system that you could run. I talked about the fact that you might have 10 LPARs before. Well, in this example, we've got 5 LPARs. So we've got 2 IBM I LPARs, okay, so they're discrete. Got a Linux LPAR and a couple of AIX LPARs. Any combination of these you want. Some big machines that I see will have hundreds of LPARs on them. Okay. So you can mix and match the different operating systems. So we've got Linux, we've got AIX, we've got IBM on it. And they're all running on a single server. And of course, you could cluster a couple of servers together to do failover using a technology called live partition mobility. You can physically move those VMs while they're running, those LPARs while they're running between bits of hardware. All right, So when it comes to managing an IBM I server, we better talk about some of the tooling that we use in order to manage it. And so I just want to explain what this tooling is and how it works. So the most common one from a point of view of external management is the hardware management console, or HMC as we refer to it. This is a Linux-based appliance which can run on a power server, can run on a standalone appliance power server, so not one with other VMs on it. It can run in a VMware estate. So it is just Linux mixed in with some management software. Fine. So it can be physical or it can be virtual. Okay, or you can mix them. You can have some physical, some virtual. A lot of people do that. They'll have one physical one and then they'll have some virtual ones because they've got some VMware or some KVM or some spare LPAL capabilities on their estate. The idea of this HMC is it changes the whole system configuration between all those LPARs. It can move memory backwards and forwards, change processes, allocate cards, and it can do that locally if you're stood there in front of it, or you can do it remotely. So for system administration, fantastic. You want to spin up a whole new LPAR, new VM, you can use the HMC to carve out some extra processor, RAM, whatever I/O adapters you need, and it will also handle all of the virtual networking, so you can share a single network adapter between multiple different LPARs. And so it allows you to change the states, power them on, power them off as well. It also, we've got this special mode called restricted state, so the machines, you can work on it, but the users can't work on it. It gives you access to that. So you might do that when you're patching it or upgrading the operating system on it. The next most common tool is the IBM ACS, the Access Client Solutions. So this is a workstation-based tool for interacting with it on a day-to-day basis. So not doing the whole and creating a new one now. It's more to do with administering it and perhaps configuring new users, setting up GUI services, setting up web servers, that sort of thing. And it runs as a single client now, and it's Java-based. So the same client can run on Windows, Linux, Mac in a traditional sort of JVM open environment, or you can run it on AIX and IBM I if you want to use some of the scripted type functions for file transfer, ODBC, and that sort of stuff. It has a command line interface because all good operating systems have a CLI, a command line interface for doing it, but it also has a GUI interface as well for dealing with things to do with file and print management. And you can use it to be embedded within scripts if you want to write some automation piece that takes a file from A, puts it in B, does some sort of transformation in C, and then sends it on somewhere else. So you can script it as well as actually running it interactively. That tool comes at no extra cost. If you've got an IBM I, you can get that tool. And then there's the Navigator for I. This is actually a web server that runs in IBM I by default, and is a sort of GUI administrator. So you might use it for setting up a new user, resetting a password, adding a TCP route, all the sorts of things that you would normally do for system administration. This one really is an unsung hero, and it's been recently redeveloped with what we call NewNav, where they've now changed it to a brand new, more open, more versatile, more flexible platform. And that really heralds what an IBM I application should look like today. It's built on SQL services and a modern open source framework for web serving. So it's responsive, and both to performance and also that responsive to different screen sizes. It's very good at dealing with that different size of a estate, whether you've got a 55-inch screen or a tablet. It runs natively on I, as I mentioned, so you don't need any client but a browser to connect to it. And that single instance of the Navigator for I, you can set it up so it can manage multiple different systems, not just the one it's connected to. So if you've got one local central server which has got access to other IBM I servers, you can connect to it and then pivot and then do user resets on other systems or performance management on other systems. So recapping those, HMC, it's for managing typically outside of the estate, and it controls system state. You don't have to have an HMC, you can just have a PC ops console, more on that later. ACS, a great way of interacting with it for system configuration, running SQL scripts, importing and exporting data from the system, getting your printouts off. It's general set of system management. And Navigator Fry, for those people who are new to the platform or just really like GUIs, it's a very intuitive way of finding out the art of the possible. And then finally, these were all sort of IBM provided things, IBM licensed things. There is a straight command line access, which is totally open, and you can get things like TN5250 to use it. There is a command line access that you can do it all in through called Telnet 5250, not standard Telnet, it's an enhanced version. And also, because you're doing open source, there's an SSH bash connection as well. Because where would Linux and open source be without bash? Yeah. Well, I'll tell you where to be, with commands that you could understand what you were typing. That's where you would be. But hey, that's my personal biases. Right, so that's the tooling. Those are the things we're going to use when we actually administer a system. Is this sinking in so far?
Yeah, absolutely.
Fantastic. Right, so how the heck do you use these things that I talked about? Well, if it's a HMC, typically there is a GUI and a command line to that HMC. The GUI, you can see there, each of those little boxes is one of these virtual machines that's on the right-hand side there. And you normally connect to it via a management LAN, and the HMC itself, whether physical or virtual, has got a private connection into the back of the server that doesn't go through the production LAN. So if there's a problem with the production LAN, you can still access it via this secure connection. But because of that, no application data goes through that private management network. I mean, it is just state and system configuration. You couldn't be doing a file download through it. It's deliberately dealt with that way to secure the machine. If you're in that view, you're there to administer. If you want to do the normal administration, you'll go through the normal network connections to get at it. All right. So what is a hardware management console? Well, if it's a physical one, it's a 1U server. Has a power chip inside it. It runs Linux, and it controls the allocation of resources to your LPARs and changes the system state. So if you've got a HMC and you ever make that mistake of powering down the machine without the restart, you don't have to take the walk of shame or the drive of shame if you're working remotely to go and press the on button in the data center. Common things you do with a HMC, power on, power off, LPARs and physical servers. Move resources from one LPAR to another. Move LPARs from one system to another. Create or remove LPARs. Do hypervisor firmware updates. Do patching of systems. Diagnose and report faults, and then do some hosting and command line access as well. Do you mind just popping and getting a charge of this? Yes. So I'll just crack on whilst you do that. One HMC could actually manage 48 physical servers and 2,000 VMs. Now, this sounds like madness to me to try and get that much into one place, but you could physically do it, and they are scalable. You can configure multiple HMCs, mixture of physical and virtual, so that you have failover, so that your HMC or management doesn't become a single point of failure. Okay. If you don't have a HMC, you can use an operations console. This is part of the ACS software. It means you can use a low-powered Windows PC. One ops console can manage multiple systems, not at the same time, but it can do them with the same systems. And many ops consoles can manage a single system, again, one at a time. And they're connected via a standard Ethernet cable to a nominated port on the back of the machine. Give the background noise there. We're not running an IBM I, my battery was in there. So my good friend out there stepped in. So it does have GUI access to the control panel and the like. So this is an operations console. If you don't have a HMC, it basically looks like a PC. It runs a piece of software part of the ACS. And if you want to know more about it, I did a video on how you connect and configure an ops console there. If you have a choice, please have a HMC. They will do more for you. If you don't, then use your ops console. When it looks like the navigator, well, what does the navigator look like? Well, it's a web page. There's the login for the web page. It is a graphical, browser-based, modern standards. It's intuitive to use. It's got searches. It's great for finding out what's possible. if you're thinking, I don't know what this thing is, you can go and search for such and such. Maybe it's to do with single sign-on, maybe it's to do with the SNMP protocol. Search, you'll find it. And we'll touch on that in just a second to show what that looks like. So basically, it makes things easier to carry out, but it's not necessarily the fastest way. If you can learn the command line, just like in Windows, just like in Linux, the GUIs are great for actually getting you to the right place and teaching you what's possible. But if you can learn the command line and learn how to script, you'll be able to work much faster. What does the command line look like? Well, typically it's called the green on black, and you can change these colors, but yeah, by default, there you can see why it's the green on black. It's lightning fast because it's just a lightweight command line interface. Right? You can do scripting in it, and it uses 3-letter acronyms as the constructs for the commands. So if you like your TLAs, this can be either heaven or hell or hell. So the most common one, for example, would be work with active jobs. So what's running on the machine? But that command comes down to 9 characters: WRK for work, ACT for active, JOB for job. Get that in your head, it's great, but trying to remember, was it work job active or work active? Oh yeah. So that can be, I can understand why people would struggle with that to begin with. Some of those constructs I was talking about, typically when you want to work part of a command, you see WRK or configure CFG, clear CLR, and so you can see how those come together on the right hand side here. If you wanted to work with your printouts, you work with spool files, WRK, SPLF. Okay, you either know it or you don't. Okay, but there are ways of finding this out. That's not really what I'm going to cover in this session. We'll do that in the future as to how you find those commands. But I just wanted to show, these are the sorts of commands if you're using the command line, and if you're using the GUI, it sort of looks like that. And there's a bit of a blowing on the GUI. So in that particular example, we're looking at users. So there's a list of users on there. Maybe we're going to do a password reset or delete a user or disable a user. So definitely can see why that would be easy to use. And that's the same sort of view for users using the work with active, work with user profiles command. So let's just take a quick look at these as to what they look like. And see what we think. So let's just come out of the presentation for a moment. Okay, and open up my ACS client. Okay. Let's put my goggles back on, ladies and gentlemen, because I am old. So we will start with the navigator for I interface. I've got my ACS over there, so let's spin up a navigator for I connection. And so it brings up a login. Okay, so I'm using there and then log into it. Save it's okay with my encryption. If I had multiple different systems I was managing, they would appear across here. So that's a system, and if there are other systems, I could click on those. It immediately tells me, whether it's healthy or not, how much CPU. But I'm just going to start just to drill in and use it. So once you go inside an active system, I've got a navigation on the left-hand side here that sort of tells me all the things. So the options are sort of grouped together. It starts to build a performance chart about CPU and storage usage at the moment. So I can see I'm in the mid-60s of storage at the moment, and I can see the CPU is just like 1%. So the CPU percentage on that. So I'm not worried about my percentage on that. But let's do that user part. So I could either go down there, pick on the thing that looks like people, and click on users, and then I'll get a list of users. Or if I couldn't figure that out, I could just in the top here in the search type in user, and it starts to give me things that have got users in them. So I might be creating a user, might be creating a user-defined service. Well, I'm just going to click on users. Okay. So you can do it through a search, you can do it through finding it in encrypts on the side. So I think it's fair to say one of the most common things that one has to do in any platform is reset someone's user, re-enable a user, change their password. Well, there's a list of users. So if I was trying to find a user called Brad, and he asked me to reset the password, well, I select it, I right click on it, I select properties, and I can change the password. New password down there. Okay. If I wanted to enable a user, so that user called a surprise has been disabled, we can see that. So we put out a phone call coming to support, say, sorry, I can't log in. Maybe they typed their password in wrong too many times, whatever reason. So again, properties, I want to enable the user. There's a box that says enable user. Tick it, click OK. Are we getting this? It's not difficult. Okay, so this is where it's super intuitive. Now you might have hundreds or even thousands of users on there. So what about easy ways of finding all the disabled users? Well, we could either change the sequence, because things are binary in this case, they're either enabled or not. So I'll just sort it and put all the disabled ones at the top. Or I could just in the filter, if you've got many things, many states in there, I could just start typing in star disabled and it'll just filter. I don't even need to finish the full word. It'll filter that out. Okay, and that works on all of those columns at the top there. You know, if I was just trying to find anyone that had STR in the name, the beginning of the name, so it's G Street, I think I saw it there. So just see, we can see that G Street's disabled. Well, let's be nice. Let's re-enable Graham Street there. There you go, Graham. You can use the system again. So filters on any of these things, and you can change the format, change these columns as well if you wanted to. So these groups are security groups. You might want to find everyone in a particular security group. So the idea of this is it's intuitive, it's fast, it's easy to use. It does way more than users. Each of these is a different category. So you can see security management there, you can see network management there. So let's just say I wanted to know about the TCP/IP configuration of this. Just tell me what connections are on the machine at the moment. Well, so these are all the different services that are listening. So I told you it was an open platform. So those are systems services listening for connections. And these are actual connections that are taking their place into it. And that's just the first 100 I see on there. If I go to the second page, imagine that eventually I will see me connecting to it. So there we go. So super intuitive. So that's the point of the GUI. But you know, like a GUI, I still have to click on things and find things. If I was living in that machine all the time, I could also take the command line interface. You'll notice mine isn't green on black. I kind of like black on white. You can change the colors how you want. If I want to do the same sort of thing, work with users, use the work with user profile command, spell it correctly, and I get a list of all the users. So if I wanted to enable or disable a particular user, I'd go in and change the state from enabled to disabled. So it's horses for courses. I don't mind if you use the GUI. I don't mind if you use the command line. I don't mind if you do a mixture of the two. I just want you to make sure you know how to do it. Right, let's just quickly switch back over again, because we're almost done, ladies and gentlemen. So what I want to do is slideshow. Let's figure out what we've learned. Yeah, right. This system is mostly self-managing. Okay, so if a database index needs to be created, if you don't create it, and it'll give you the advice on what needs creating, it'll do it for you. If objects need moving from disk A to disk B or balancing across multiple disks, it'll do that for you. Right, mostly self-managing. There are multiple tools you can use to administer it, and you can mix and match. So pick your favorite and pick your favorite for a particular task. For me, if I'm doing performance management, I always use the GUI. But if I'm doing user enablement, I always use the command line. Yeah. You can mix and match those as you want them. It doesn't have to be difficult. You know, if you figure out how to do something in the GUI, then you can Google how to do it in the command line. Once you know something's possible, it's very easy to figure it out. So with that, that gets us to the end of the things I wanted to share with you. So Matt, that was a whistle-stop tour of what's a power system in general, what's an IBM I. How are you feeling?
Yeah, good.
Fantastic. Well, we'll do more with Matt, and believe me, there will be more questions coming from him in the future. At the moment, he's sitting there thinking, okay, what is it that I've signed up? So I'm going to stop at this point.
I was going to say, I suppose the one question is when we talk about HMCs and the iManagement console as well.
Yeah.
Is there a specific perk to using one or the other?
Fantastic question. So there are a number of perks of the HMC. You can do a much more performance tuning in there, particularly if you've got more LPARs, more than just one LPAR on there. So you can start sharing processors across multiple LPARs in a sort of a clever lend to each other kind of way. You've got more options for turning the machine on and off. You've got more options for spinning up extra workloads without actually any downtime. And you can also if you've got the right environment, you can even overclock some environments to get better performance out of it. So there are some performance benefits if you've got a more complicated environment. From a system administrator's point of view, the main thing is that you've got a reliable, bomb-proof console that you can access locally or remotely in those times of need. You know, when you're doing operating system upgrades or patching, you don't have to be worrying about your console appearing and disappearing because it's done a Windows update. So that would be my main answer to that.
And how about the difference between a physical and a virtual HMC?
Absolutely not. So it's the same code, works identically, the interface looks identical. The one question of why some people put a physical one on there is if you are doing a disaster recovery, the entire site has gone offline, you wouldn't want to necessarily wait for the VMware or KVM estate to be reinstantiated and built before you could get your console to start bringing up your power and IBM estate. So I'd always have one physical one that's just there in case of the power went out to the building, we've got to power everything up. I can get my stuff up at the same time as the VMware guys, but there afterwards or remotely, the code literally is identical. So it's a good question, but yeah, just from a point of view of DR and stability, I have one physical one.
Okay, yeah. Yep, all sorted.
Yeah, brilliant. Glad you got the questions. Thank you very much, Matt. If you're interested, we'll see you soon.